We are going to be covering APCSA Unit 1 today, and I'm here to teach way better than your teacher can. This class uses Java as its programming language. With that said, we're going to go over stuff like primitive control, stuff like the basic operators. We're going to go over the data types. First and foremost, I want to explain to us what exactly an object-oriented language is. Okay, so what we're going to be doing here is we're going to compare it to like games that are coded in object-oriented languages. And the perfect example for that is a game that is coded in Java, Minecraft. Okay, so Minecraft, being coded in Java, being coded in an object-oriented language, it is based around things called objects. So what is an object? I'm assuming all of us have played Minecraft. An object would be something like the player. An object would be a block. An object would be a sheep, a cow, an entity, a mob. Okay, so if I have a sheep right here, that sheep would be my object. Now, in object-oriented languages, objects have attributes. They have characteristics, okay? So sheep, we're going to call it, spawns in like a plains biome. That would be one of its attributes, spawns in a plains biome. Another attribute would be it has 20 HP. Another attribute would be its color. It might be white, it might be black. The attributes are not intrinsic to the object. The attributes can be modified, but the overall object, the sheep, stays the same. Okay? For example, the sheep could be white, black, pink, etc. The HP of the sheep is going to start at 20 always, but the HP diminishes. Like we could have a sheep with 16 HP because it's taken damage. It would be like stuff like movement patterns. Those would be things called methods, which are also intrinsic to an object. If a sheep can baa, that would be an example of a method, a behavior of the object. Attributes are characteristics of the object. Methods are things the object does. The sheep moves, the sheep baas, the sheep eats grass. You get the idea. So we're going to cover all of this a lot more in depth in the objects unit, which is unit 4, but I just want to give you guys some background as to what exactly an object-oriented language is. And the first thing we're going to look at is the all too famous hello world. Okay, so I have some starter code here. We're not supposed to know what this starter code means just yet. That's going to be covered in a later unit. But first and foremost, we're going to learn this. The System.out.print. Okay, now spelling is very, very important in programming languages such as Java. So you'll notice here that the S in system is capital. If you put a lowercase, you will get points off, your thing will not compile. Okay, so let me write everything out here so we can analyze it later. Okay, so what did I just write? This right here is my command, my System.out.print. I'm telling the system to print something out. Okay, and inside my parentheses here is what exactly am I telling it to print out. That's what goes inside the parentheses. Okay, so hello world, that's what I'm telling it to print out. Now at the end of my line of code here, I have a semicolon. Semicolon functions as a period in Java, meaning it is how you punctuate things. It is how you close lines of code. If you forget to put a semicolon, you get points off, your thing doesn't compile. You need to put a semicolon at the end of each line of code. The reason we put a semicolon is, like, let's say I wanted to write this like this. A line break does not end the execution. Only a semicolon ends the execution. So if I were to compile it like this, it should execute the exact same way. Okay? The processor keeps iterating through the line of code and processing it and acting on it until it hits that semicolon. So let me press compile and run, and as you'll see here, on my output screen, I have a hello world, and it's surrounded by a bunch of other gibberish that isn't particularly important to us, but it printed out the hello world like we told it to. This brings us to our discussion of data types. So we have 4 basic types of data types that we're going to be covering in this class. That's going to be the integer, the Boolean, the string, and the double. Okay? Those are going to be the primitive data types. Hello world is a string, a list of letters, list of words, a connection of, like, abacadabra is a string. It's a collection of letters. It doesn't need to be a real word, it just needs to be letters. Okay, so this is going to be an example of a string. It's letters. And the reason we tell it's a string is because it is surrounded by quotation marks. Quotation marks is your signaling to the computer that this is a string. So if this weren't in quotation marks, it wouldn't be a string anymore. In fact, if it weren't in quotation marks, this would be treated as a reference to something else. Okay, and we're going to cover that in just a moment. So when we get a string or a word encased in quotation marks, we call that a string literal. A string literal. Let's talk about what I referenced before about what happens when I take this out of quotation marks. What happens then? As the code is right now, it won't compile because you didn't pass a string, you didn't pass a word into the System.out.print. The computer does not know what to print out. So what happens here is you passed an identifier, a name. You passed a name into the System.out.print, and the computer says, okay, I'm supposed to print abacadabra. Where is abacadabra? Let me find abacadabra. It's looking for a data type, it's looking for a variable that matches that identifier. So let me show you what that means. If I create a string abacadabra and I set that equal to my hello world string, and don't forget the semicolon, this is what I was talking about, okay? The computer is searching for abacadabra, and this is where abacadabra is declared. I'm declaring that there is a string called abacadabra. Okay, and what is abacadabra? Abacadabra is the string literal hello world. So if I then recompile this, it's going to print out my hello world, this time in all caps like I typed it here. Okay, so in this form, it is a string. It is a literal word, but in this case, it's an identifier. It's a reference to something else. It is the name, the identifier of a variable, a string variable. If you don't know what a variable is, it's just a place where a data or something is stored, okay? So I'm storing the string literal hello world inside the abacadabra variable. So what this is it's looking for the abacadabra variable. And whenever I declare a variable, I need to specify what type it is. In this case, it's a string named abacadabra that stores this. Okay, let's move on to our discussion of a primitive type versus a reference type. So let me go back to my drawing board here. So right here, I'm going to have primitive types, and on the right, I'm going to have reference types. So a primitive data type, we're talking about data types here, we're talking about variables. A primitive data type would be things like your integer, things like your double, things like your Boolean. If you've never heard of those, an integer data type, as you might expect, is an integer. It is a single number, a number that has no decimal places. A double is a number that has decimal places. And a Boolean is a true-false statement. Like we discussed before, you have data types and you assign them a name. You assign them an identifier, like we had abacadabra in the previous example. Okay, so that was a string type. String is a reference type because it is an object. And we're going to discuss reference in just a moment. The primitive types are your int, your double, and your Boolean. A Boolean, like I said before, is true-false. So if I call the identifier, let's say I named it b, if I look for b and I look inside b, the variable b, it's either going to say true or it's going to say false. It's like a binary. That is how a primitive data type works. A primitive data type is a data type where I go to the identifier, let's say b again, I go to b and I look inside b. All right, what's inside b? It's false in the case of a Boolean. It's the number 2 in the case of an integer, or it's 3.14159 in the case of a double. A reference type is something else. A reference type, let's say a reference type has the identifier C. I go to C, I look inside C, and inside C I find a treasure map. Now it's not actually a treasure map. When I look inside C, I find I find a list of numbers like 6, 8749, and I find like a list of numbers, okay? And that list of numbers is a treasure map. So if I follow that list of numbers, if I follow that treasure map, it leads me to the actual data that is stored there. So if I look inside the string, which has the identifier C, I'm going to find this reference number. And if the computer follows that reference number, if the computer follows the treasure map, then it's going to find the actual string stored with that identifier, hello world in this case. So let's go over the ways we create variables. We declare variables is the word we use in the computer science world. So if I wanted to create, if I wanted to store an integer value, I would say int, let's say num equals 2, okay? And you see it follows the same syntax as my first statement. First, it's the type of data that I'm trying to store. Then I write the name or the identifier. Then I write the equals operator. And then I write what I'm trying to store there. In this case, the number 2. Maybe I want to store a double value. That's not how you spell double. Double pi equals 3.14159. Now, we're not going to get into declaring objects until we get to the object unit. So let's say I wanted to print pi. If I wanted to print out the number pi, I could either type into my braces here 3.14159, and I could compile that, and it would print out my 3.14159. Or I could reference the variable that I just declared. I could say, hey, print out pi, and the computer's going to look for pi, it's going to find it, and it's going to print out the value that is stored there. Okay? Now let's talk about how we change the values of variables. So this statement was my creating the variable. Changing the variable means you just need to identify it by the name, and you can just say pi equals 3.14, okay? And there I have just redeclared the value of pi. Pi no longer contains 3.14159, it now only contains 3.14. And I'm going to show you that by printing out pi yet again. And if we compile it now, you'll see here we have our 3.14159, and then the computer printed out right after it our 3.14. Okay, why is it smushed together? I don't like it smushed together. Well, that's because of the commands we're using. We're using System.out.print, which just sequentially prints on the command line, or the terminal, I should say. We can do what is called System.out.print ln. What that does is it prints out whatever's in parentheses and then inserts a line break. It's like pressing enter. So with the ln command, it's important to know that the line break is entered after the print. So if I add ln's to both of these, and I print out again, you'll notice that first I get my 3.14159, then the computer skips a line, prints out 3.14, then it skips a line again, and I get all the gibberish that followed after this. So that brings us to our next topic, which is final variables. Final variables is declared like this: final double pi equals 3.1415. And if you declare a variable as final, it means that variable can never be changed. The value can never be altered. Okay? And that's useful when you are writing functions or methods that are expected to change variables, and you don't want that to happen. It's initially set at 3.14159, so we got an error here. Why did we get an error? Because in our code, we tried to redefine a final variable. We tried to put something new into a box that we had already chained it shut. So the computer didn't like that, said, we got an error here. You're trying to alter a variable that can't be altered. That's how final variables work. So moving on from there, we have the math operations. Okay, the math operations are pretty simple. You have the addition, you have the subtraction, you have the multiplication denoted by the star. If you have a keyboard with a number pad, you'll see the star is right there. It means multiplication. And then you have the slash, which is division. Okay, those should be fairly intuitive so far. And the fifth operation, which isn't so intuitive, is the ampersand. That's not the ampersand, I'm sorry, the percent symbol. The percent symbol is the remainder operator. And we're going to see all of those in action right now. Okay, if I declare int num as 2, and I print out my number, and then I want to redefine num as 2 plus 2, 2 and 4, as we expect. Okay, so we all did third grade math. We all know how to do multiplication, addition, subtraction. Keep in mind, order of operations, PEMDAS, is in effect. Division and multiplication are always done before addition and subtraction. We can always put in parentheses if we want to prioritize a certain operation over another. So if I run in this case, we're going to get 4 times 2, which gives us 8. Now let me demonstrate to you what the percent symbol does, what the remainder operator does. It effectively says, let me do this division, and let me find out what the remainder of that division is. So, for example, I have 8 here on the left side of my percent symbol, and let me try and divide that by 3. Okay? Let's do the math in our head. 8 divided by 3 is going to be 2 with a remainder of 2, because it's 6 divided by 3 with a remainder of 2. If I then do this operation, the computer will spit out what the remainder is, and the remainder is going to be 2, as you will now see demonstrated, 2 and 2. So if instead I wanted to have 16 divided by 3 and I wanted to know the remainder, by the way, from here on out, I'm going to say 16 mod 3. That's how the math community says it. If I want to find the remainder of 16 divided by 3, the way you say that is 16 mod 3. So if I want to find 16 mod 3, now this is what my computer is going to spit out, which is 1. 15 divided by 3, 16 gives me a remainder of 1. So now that we're doing operations, we need to know how those operations alter our data types, because we can, let's say, do an operation between a double, like 3.14159, and an integer, times 2. Okay? So, first of all, I want to delete the final in front of my pi so I can modify it like this. And if I compile this, I first get spit out a double, and again I get spit out a double. Reason for this being is that if I take any double and I multiply it by an integer, my resultant is going to be a double. If I take any double multiplied by a double, or any operation for that matter, I'm going to get a double. If I get an integer plus an integer minus an integer, only then do I get an integer resultant. And we're going to demonstrate that right now, like 3.000. This is a double, even though 3 is like a conventional counting number. Okay, it still is a double because it has decimal places. So we're going to say pi equals pi times 2. This is going to say that our new pi is going to contain our original value of pi, 3.000, multiplied by 2. If we print that out, 3.0 times 6.0. A double multiplied by an integer gives you a double. Okay? As you can see here by the presence of our decimal place. If I instead take an integer multiplied by an integer, num equals num times num, which in this case is going to be our new value of num, is going to be equal to our original value times itself, 2 times 2. Only then, I'm still printing out pi, I'm sorry for that, only then do we get an integer value put out. Okay? So here I want to take the time to discuss the significance of the equals operator, because it doesn't do the same thing that you would expect it to do in a math class. So there are 2 equals operators, well 3 actually, but the other 2 will be discussed much later in the course. So in order to understand the difference between all 3, we first need to fundamentally understand what this first one means. Okay, so the equals operator is placed in between 2 things like this, and it's basically saying, okay, the thing on the left of me is what I am modifying. It basically reads as the thing on the left is going to contain the thing on the right. Okay? That's what it means. I'm not saying that 2 equals 2 times 2. It's not what I'm saying with the equals operator. The equals operator says the thing on the left is now going to contain the thing on the right once the code has been executed. You're not going to get like an infinite loop here because I'm using the same variable in my code here. Num is the left side of the equal sign is only going to contain the stuff on the right after the computer reaches the semicolon. Okay? So it's not going to like do a numception or anything like that. The computer does 2 times 2, it gets to 4. Now the computer holds the number 4, and once it gets to the semicolon, says, now num equals 4. The value stored in the num variable is 4. So now we have our compound operators, like plus equals, minus equals, times equals. Pretty simple to understand. This part right here, num equals num times num, or let me simplify it as num times 3. I could rewrite this as num times equals, where's my equals key? There it is, 3. Okay, this statement is exactly the same as this statement. Times equals means num equals num times 3. Num plus equals 3. Num equals num plus 3. Now num equals 5. Okay? Those are your compound operators. And they work with all of the operators. Aside from that, we have the plus plus and minus minus operator. So num plus plus basically adds 1 to the number contained in num. Let me demonstrate that for you. I can write it like this, num plus plus with a semicolon. And then if I print out num, it's going to be 3, because 2 plus 1 is 3, as demonstrated right there. You can do num minus minus, which is going to be the value of num subtracted by 1. You're going to see these are useful in upcoming units. Now it's going to print out 1. Now from there, we are going to be doing integer casting. You can cast 2 ways. You can either cast a double to an int, or you can cast an int to a double. Now what do I mean by that? Casting basically means transferring or transitioning the data type. If I have an int ex equals 6, sorry, I need to name my double. Double exp equals ex. And now I'm going to System.out.print ln my exp. So you'll notice here I have an integer value, and that integer value is 6, but I cast it as a double. I took my integer value and I converted it to a double value. So now it's output as a double, 6 with a decimal place. Okay? Now, this is a casting that is allowed by the computer. The reason it's allowed is because it does not involve the deletion or the loss of data. Okay, if I have 6, I'm not going to lose any data by converting it to 6.000. However, if I have 3.1 and I declare that as a double 3.1, and I want to convert 3.1 to an integer, now I have a problem. Because if I convert 3.1 to an integer, I'm losing data, I'm losing information, and the computer returns an error if you try to do that, as I demonstrate right now. It calls it a lossy conversion. So the way I get around that is I do casting with this sort of syntax. I cast as an int, and I put that in parentheses, the value ex. And what this code does is it basically takes ex, the double 3.1, and it forcibly converts it to an int against the computer's will. Okay, and what that does is it takes 3.1 and it chops off the decimal place. So now it just becomes the number 3. It forcibly loses data. And if I compile now, I'm going to get 3. I lost my 0.1. Okay, that's going to be our entire day with Unit 1. If you need extra help, I've got a Discord server. Please join that. Tutor you guys, help you guys. I'm a counselor for college stuff.